Strain. Deformation of a body due to the application of a force on it may be small or large in magnitude, depending on the amount of force applied. When a solid is subject to a deforming force, a restoring force develops in the solid to counter it. This restoring force is equal to the deforming force in magnitude, but is opposite in direction to it. Restoring force developed in the solid per unit area is known as stress. Thus, if the force applied on an area of cross-section A is F, then magnitude of stress equals F by A. The SI unit of stress is Newton per meter square. Pascal, PA, may also be used as a unit. Stress has the dimensional formula ml raised to minus 1t raised to minus 2. A solid may get deformed due to an external force in three different ways. When a solid is deformed by the application of forces normal to its cross-sectional area, such that it is compressed, then the force is known as compressive stress. Similarly, if such a force acts to expand the solid, then the restoring force per unit area is known as tensile stress. Both these forces taken together can be generalized as longitudinal stress. Longitudinal stress results in change in length of the cylinder. The ratio of change in length of the solid to the original length is known as longitudinal strain. If two equal and opposite deforming forces are applied parallel to the cross-sectional area of the solid, then the opposite faces of the solid undergo relative displacement. This deformation, occurring due to the application of tangential forces on the solid, is known as tangential or shearing stress. The strain caused due to the relative displacement delta x between the opposing faces of the solid is known as shearing strain. It is defined as the ratio between the relative displacement of the faces delta x and the length of the solid L. Shearing strain equals delta x by L equals tan theta. Here, theta is the angular displacement of the solid from its original position. When a solid is placed inside a fluid, it is compressed from all sides. At each point on the surface of the solid, the pressure acting is perpendicular to the surface of the solid. This is known as hydraulic compression. In response to this compression, the body develops restoring forces within itself. This internal restoring force per unit area is known as hydraulic stress. It is equal to the hydraulic pressure on the solid in magnitude. Strain produced in case of hydraulic stress is defined as the ratio of the change in volume as compared to the original volume. It is known as volume strain. Strain is a ratio of change of the same quantity with respect to itself, and hence has no unit or dimensional formula.